What questions do you guys have? 7? Not 7? You guys are carefully comparing this to the right version of what they give you, right? Remember, there are 2 different ways of writing the differential equation for logistic, right, Ethan? There are 2 different ways of writing the equation for the logistic growth, right? What's one differential equation for logistic? That's one way, but is that this one? No. So what's the other way? Good. You bring the L out. When you bring the L out, there's a 1, and then there's an over L, right? Good. You factor out the L. So what's this one? It's almost the second one. How can we make it the second one? There's a 2 when I need a 1. So what should I have done? Divided everything by 2. If I had divided by 2, I would have had 2p times 1 minus p over who? There's my L. Or what you could have done is you could have pulled out the 1 over 5,000. And if you had pulled out the 1 over 5,000, that would have been 1 over 5,000 p. Pulling out this, that would have just been a p, like my minus y, and pulling out a 1 over 5,000 is multiplying by the reciprocal. So you would have had 10,000. So there's your L. Either way you do it. Yeah. Yeah.
The 3 and the 2 work for the second one. How did we figure it out for the first?
For what integer will both converge? Okay, because it's geometric, right? That's how you figured out the 3 and the 2. And then you're looking over here for the 3 and the 2. Just think 3 would be odd powers, so alternating. 2 would be even powers, so not alternating. So I'm guessing that this is not absolutely convergent. It needs the alternator. So if you plug in, check it. If you plug in 2, 2n, it'd be negative 1 squared to the n. Well, the problem is with negative 1 squared, technically, the 2n. That's 1 over n diverges p series.
I thought since it was, if you did the 3, it would be like oscillating between, because it would go from positive to negative.
Yeah, but remember, it'd be oscillating as n grows. It'd be an alternating series, and the limit as a sub n goes to infinity, as n goes to infinity is 0. So then it would converge, yeah. So this one, the 1 over n p series, only converges if I have the alternator, so I need the alternator. Gabby. Okay. Let f be a function defined and continuous on the closed interval. Okay, so now we know what IVT applies, EVT applies. If f has a relative max at c in between a to b, which of the following statements must be true? We can go looking at this right away, but you can also think what the theorems guarantee first. So I know that f is defined and continuous. What does it not say? It does not say differentiable. Differentiable, able to be derived. So could you have some derivatives that don't exist? You could have some sharp points. So right away, even though I have a relative max, I could have a nice 0 at the relative max, or I could have a pointed sharp point. I can't have an endpoint being the relative max, like it wasn't like cut off at a high because it's in between. Does that make sense? Okay, so I know sharp points or horizontal tangents. So either critical number is valid. If it said differentiable, I would know it'd have to be a 0. But it doesn't say differentiable. So f prime exists. Well, it doesn't say differentiable. It doesn't have to. It could be DNE, like the critical numbers. So that's my no. If f prime exists, then f prime equals 0. Well, yeah, if it's either this or this, that would be DNE. So if it does exist, there must have been a 0. So that's a yes. And then if f double prime exists, then f double prime has to be, yeah, because to be a max, it had to be counted. Yeah. It's all about the differentiable. That was missing. Lucy.
When you said like f prime is doesn't exist, but all the rest say, oh, that's just it.
Yeah.
Is that why?
Right.
Okay.
Right. So say does have to exist. It says if it does, then it's a horizontal tangent, then you have concavity down. Go. Any other questions on multiple choice, Carolyn? 6. If a sub n times x to the n is a Taylor series that converges, then f prime of 1 is equal to. Okay. What I did is, they said Taylor series, so I made a Taylor series. So I plugged in when n is 0, n is 1, n is 2, n is 3. Because this will converge to that. So if I could write out the Taylor series, I can say that these are equal. And so then when it says find f prime of 1, I can take the derivative term by term. Derivative of a constant 0, derivative of an x term is just the constant. Derivative of constant would bring down the 2. So I literally just made my Taylor series plugging in 0, 1, 2, 3. Derived my Taylor series because it's easy term by term. Plugged in 1. And when you plug in 1, then you get, now, here's where it's a little bit funny because, first of all, it doesn't cancel out to 0. That's a no. There's a lot more than just a sub 1, so that's a no. And then the rest of the other 3 are summations. So I have to figure out which of these summations fits what I have. But this one would be 1 a sub 1, 2 a sub 2, 3 a sub 3. Oh, that's the right one. Sorry. This one would be 1 a sub 1 to the 1, 2 a sub 2 to the 1, 3 a sub 3 squared. So this one, you don't see it right away because it will match up for this and this, but it won't match up there. Oh, I see what you're saying as far as plugging in. No, you technically can because this is a polynomial expression and this matches this guy. So you could take the derivative, bring down the n, and it's n minus 1, but here's the struggle. What are you supposed to plug in? 1. 1 to the n minus 1 is just 1. So there shouldn't have been an n minus 1 remaining. Does that make sense? Yeah. That's true. I guess I did it the hard way. You could have just done the power rule. Anything else? Multiple choice? Alan? Okay, so length, arc length, given parametric equations, we can just do x prime squared plus y prime squared, right? So that's from our, now hold on, I did something that's horribly dangerous. If this was an FRQ, I did not write my DT. I must have been grading your guys' FRQs at the same time and copying your mistakes. That's more an AB mistake, but there were a couple BCers last night that made that one again. But good thing it's a multiple choice. Whew. So I just had to go ahead and take x prime, take y prime, plug into my. So think whenever you see the length of the path, that's talking about arc length. Guys, what's the one weird arc length formula that we had to add to our card? Not parametric, it was polar. Wasn't there a weird polar one? Yeah. Yeah. It's a lot easier than having to convert it and then get it in. Alan?
3.
And then which one do you have? Oh, good. Same thing? Okay, so number 3. It's an improper integral. Now, guys, hold on, pause. I need everyone's eyes up here because so many of you missed this on. Well, actually, I don't remember if this was the makeup one or the regular one, but either way, it was missed by multiple people. This idea. A lot of people in BC would look at this integral and be like, oh, okay, whew, integration by parts. A lot of people would think that, though. So don't go saying I would never, just okay. And a lot of people did. Yeah, I think it was the actual BC class, because I was grading like the rest of the actual BC and then the mock. Anyway, this happened time and time and time again, and it's so sad. And they're trying to trick you because you've learned integration by parts. Do we usually use integration by parts with a polynomial and an exponential? Yes. They're usually giving you a hard problem, or a polynomial and a trig, or a polynomial and. But what do you always have to remember? AB. U sub. Always try U sub. Because U sub, U is equal to negative x cubed. What's du? Negative 3x. Ah, it wasn't integration by parts. And on that one FRQ, if you guys remember taking one, there was an improper integral. It was not integration by parts. On one of the parts. Actually, I think it was the makeup one. And then on the next one, they added an x, and all of a sudden you had to do integration by parts. But the first one was just a u sub. Oh, kills me. Corey.
If you did integration by parts, would, like, you could still
How? Because usually you would make u this. You can't integrate that without a u prime, without a du, right? So if you had tried, you would have done illegal integration. You would have been like, oh, e to the u is e to the u. No, because you have to have du, negative 3x squared, and what are you going to do?
Oh, really?
So you skipped the u sub. No. But this is good. Can we get 2 for our own good? Yeah. I know a lot of you can do mental math with integration, but do you have to think through the steps of u substitution? Who is u? Who is du? Work it out, and if you're not writing it down, think about it step by step. Cameron's going to go ahead and pass back your guys' BC reviews number 3 that have been graded. As he does so, you guys know what to do now, right? Okay, what else do we have? Thanks for bringing up that question. That was great. FRQ? Sure. Let's go for it. Which one? Oh, the only second one, right? Thank you. Okay, what part, Alan?
Can we do A and D?
Okay, A, the key word is estimate, because with the table, it's impossible to solve for the actual derivative. Pause. Hey, guys, with the table, it's impossible. Hold on. With the table, it's impossible to solve for an actual, like a specific derivative, right? Okay. Why is it possible to solve for an actual definite integral, even though it's impossible to solve for an actual definite, like specific derivative? How can we solve an actual definite integral? Another mistake I saw time and time and time again, and we've talked about it since you took the mock AP. How is it possible with a table to solve for an integral, but not a derivative?
If it's the integral of, like, f prime, and the table has f in it.
If my, yeah, although it doesn't write so good, so let's forget him. Because I don't think this one writes so good. If I have x and f, and I need the integral of, let's just say, a to b of f prime, a lot of people would be like, oh, it's impossible to solve that exactly. I'll do a Riemann sum. No, you can't do a Riemann sum unless you have f primes. It's just FTC, right? How would you solve it? F of b minus f of a is the exact non-estimated integral. So I can integrate as long as I have the derivative in here and the antiderivative out here. I can integrate exactly, but I cannot, hey, look, you can do letter B exactly, but A is approximately, because at 4, number 1, I have no clue what's going on as far as the point, and number 2, I can't take the instantaneous rate, so what do? Average rate, f of b minus f of a all over b minus a. What was the other one, letter C?
D.
D. Good job getting letter B, though. That was one a lot of you guys missed. Wasn't that on the AP, the integral of f double prime, of f primes, and you had to plug in? Sure. Thanks, bud. And you got 5? Yeah. Letter D. Suppose f prime of 5 equals 3. Corey, shh, whisper. F prime of 5 is equal to 3, and f double prime. So I have a function. F is increasing at 5, and it's concave down, right? So f is increasing and concave down. Use the line tangent to the graph at, have you found that yet? No, so you have to make it. So that's just going ahead and plugging in with y minus, we have our point that they gave us somewhere. What am I doing, 5? At 5. So 5, negative 2. So I can use my table values from up above. So I'm using that point. I can plug in, or, oh, just steal my slope. There we go. Use the line tangent to show that f of 7 is f of 7. I'm approximating at x equals 7. So I would plug in, and I'd have y. F of 7 can be approximated by y, which would be negative 2 plus 3 times 7 minus 5, which would be 2. 2 and 3 is 6. 6 minus 2 is 4. So if my approximation is 4, how on earth can I say that it's an under approximation? I know my second derivative is concave down, which means that a tangent line approximation would be an over approximation. So if the tangent line says 4, my actual value must be below. Does that make sense? So I would go ahead and use the concavity. Since f double prime is less than 0, then the tangent line over approximates, so f of 7 must be less than or equal to 4. Then it says use the secant line. Hey, hold on. I heard a lot of people asking about secant lines yesterday in class. So tell me what you learned, what you figured out. What are we doing with secant lines? Slope between 2 points. And where are the 2 points? 5 and 8. So we're looking at these 2 points for the secant line. And so for the secant line, we look at those 2 points. I do go ahead and still make a line. It's not going to be a tangent line. It's going to be a secant line. Now hold on, secant line. I need a y minus y1, right? But do I care which one I use if I'm looking at both? No. When you make an equation of a line, if you have 2 points on the line, either one's okay. So you could have chosen either one. I'll just choose the same one, y plus 2. But I'm not going to plug in this exact 3. Instead, what am I going to plug in? The slope between. Good. And it's not the same slope between that we did for letter A, because that was 4, which is in between 3 and 5. Now I'm going between 5 and 8. And if you want to be super, super safe, can't you just do 3 minus negative 2 all over 8 minus 5, right? What's it ask me to do with that? To show that
I think you would just do it.
Plug in 7. But this time, since the secant line is going through concave down, what kind of approximation will the secant line give me? Oh yeah, because 7's in between 5 and 8. Okay, good. 7's in between 5 and 8, so the secant line will be below the actual value. So the secant line will under approximate. And once again, since the concavity is down, secant line will under approximate for that region. So therefore, the actual value is above. Caroline.
So for part B,
Yeah.
when they say that they want to actually work, and then like in the end they give you the explain. If you don't explain much about it, is your work not enough to show that
It actually doesn't say to justify or explain. Does that make sense? Usually we do want to put words to our math, but when it says use the line tangent, use the secant line to show. Your work for solving and getting f of 7, the tangent line approximation is 4, doesn't show that f of 7 is less than or equal to 4, because that tangent line could sometimes be above and sometimes be below. So you need to state the concavity to talk about the tangent line of a graph, then it shows. Does that make sense? So you had to add some words just because the math itself only shows that the tangent line equals 4. That doesn't tell me whether that's an under or over unless I think about concavity, because it could be one or the other depending on the problem. And then for the secant line, when the secant line approximation ended up being, what was it, 4/3? Same thing. All we know is that the secant line approximates 4/3 without bringing in the concavity. And the over or under approximates, I wouldn't be able to know.
and also when they split up the interval,
Yeah.
if you don't split up the interval, you don't get the point if you just went straight into the integration.
If you, from what I can see, if you use the fundamental theorem of calculus to solve in any way, shape, or form, as far as to integrate f prime, you need f of 13 minus f of 2. If you used that at all, you get 1 point. But if you messed up in the integration anywhere else, then that would lose your second point.
It's not necessary to split them because I didn't split them, but I still
Oh, you mean splitting. Well, they're not splitting the bounds. Sorry, I didn't see what you meant. They're not splitting the bounds. They're just doing him, then doing that guy. No, you're okay. Because this is just them showing work as to how some kids could have done it, but you can go straight to here. That's okay. That's okay. Now I understand. Any other FRQ or multiple choice questions on BC review number 4? Sweet, let's pass it up. Get it out of your life. I think Cameron might be able to grade it and get it back to you guys before we leave. That way we're all nice and caught up and we don't have like 2 reviews that you're dealing with and stressing with and all that jazz. Thank you, thank you. You guys cool working on number 5 and I try to get a few things ready for kids that need their APs early? Okay. Any more number? Thanks, Amy. Thanks, Karen. All right. Katrina, whenever you're watching this, hope you're having fun in Kansas with your sparkly red shoes.